definitely seems a little old. However, the purpose of the data being old is that it directly relates to a great equation and graph that we can kind of look at and talk about. So sometimes, yes, you're going to be given information with older data because there is definitely a relationship that appears in the data at that time in history. And 1984 kind of was, I mean, we're looking at 40 or 36 years ago. So that was definitely a while ago when computers started to kind of creep into households. So in this question, yesterday at the very end, I held you an extra minute, but I kind of wanted you to recognize that anytime we use numbers or years, we have to represent years with numerical values. So I cannot enter into the calculator 1984 because the calculator thinks that number is 1,984. And that's not the number we're talking about. We're actually talking about the year 0, the initial year of the data that's given to us. So the first year they give us, the initial year, the original year, is year 0. And then you just count up because the years are increasing just by 1. So we continue to count up by 1. So when you enter all of that information in your calculator, you should have gotten a positive correlation. So when you graphed it, you should have seen that it was increasing positively. And then the correlation coefficient should have been 0.99. So if you looked at your graph, when you hit the graph, you should have seen that those points are very close to being linear. Because remember, if this is 1, it's a perfect line, perfectly linear. But if that number is really close to 1, then the data points are really close to fitting on a straight line. One point might be slightly off, maybe another point might be slightly off, but they're all going to be touching that line. They just might not be in the center of the line. So if you look at C, Jaylyn, can you give me the equation that you found for C? I'm sorry, Jaden, can you give me the equation that you found for C?
Oh, sorry.
No, it's okay.
Yeah, I found y equals 2.53x plus 11.82.
Perfect. Nice job.
Thank you.
So we have our slope, we have the y-intercept. I'm going to skip down a couple of questions and look at letter G, where it says, what does the slope mean? So I know I'm skipping a few, but there were a couple of people that were asking about questions later down the line here. So I know that the slope is 2.53. And I'm going to just place it over 1. Because we have to think of the slope as being rise over run, or y over x. And when you're trying to write a sentence about what does the slope mean, sometimes thinking about it as a fraction, as being a rise over run value, might help you write the sentence as kind of relating what it means. If you go to the chart, I can see in the chart that my x term is the year. Yes, I know it says t because usually t represents time. And the percentage they're saying is b, but really that represents our y value. So thinking about rise over run and the fact that we have years and a percentage, is somebody able to give us a sentence about what does the slope mean in the context of this problem? Alyssa, what do you have?
Maybe like as the years go on, more people have computers in their households.
Sure, yeah, and that makes sense, right? I mean, today everybody has some type of device because the district is giving everybody an iPad. So even if you don't have a computer, everybody has some type of device in our district that would go to our school. So as the years go on, maybe we'll say more households own computers, or the number of households that own computers increase? So something to that effect. You could say every year 2.53 more households own a computer. That would be another way to actually use the number in the problem. Or each year there is an increase of 2.53 households, 2.53% of households that own a computer. So you can kind of word that in a couple of different ways. I always get nervous because my husband teaches English, and I try and make sure I word this like semi-correct in the English sense. He probably would still shake his head at the way I have this worded, but as long as you're getting the fact that as years go on, as time increases, there are more households owning a computer. Ava, question.
Yeah, so I thought that time always had to be y because I thought like if you were saying it, it would be something like miles per hour. You know what I mean?
Correct. So when you say, it's good you bring that up. So if you're saying miles per hour, slope is rise over run. The rise value is y, and the run value is x. So the denominator is always x, and that's always our time.
Okay.
So the numerator is the y value, the denominator is the x, and x is always time because it's always like, as you said, miles per hour or something per year, something per minute. So that's why the x value is in the denominator. I know that's weird to think about because in the chart, the x is on the top of the chart. But when you're thinking about slope, the run value is the denominator of the fraction.
Okay, thank you.
Yeah, good question to ask. Good to clarify. Any other questions? All right, so if we look at letter H, it wants us to find the x-intercept, which I know I could take the equation and set it equal to 0. This one's a good question. Jordan, can you tell me what you found for the x-intercept after solving for x?
I got negative 4.67.
That's perfect. And because it's an x-intercept, I'm just going to cheat here and write a comma 0 and make it an ordered pair. Now here's the question that a lot of people had. How do we write this as a sentence? What does it mean? First of all, I have a negative x number. So we have to kind of decide, what does that negative 4.67 mean in this situation? So what we were talking about before, I'm going to use this, what I have right here for slope, just to kind of label the information. So this is our year, because x represents the year, and the 0 would be the percent that own a computer. Sometimes making a little like setup as to what the data represents might help you make a sentence. So if you go into your chart, we have to decide what negative 4.67 represents. And I have that it's a year. 0 corresponds with 1984. So what does it mean if we have a negative year? What does that negative 4.67 mean? Maddie, do you have an idea of what that negative 4.67 would mean when we're talking about years and having a negative number?
Would that mean that like every 4 years that you go backwards? Like
Yeah. So
back every 4 years, then 0 households would have computers.
excellent. That's right. So she said because it's negative, we have to go back Like we're going backwards in time. Maddie, if we started in the year 1984, that was our first year, and we went, backwards in time. We have to go back in time, actually 4.67 years. Do you know what year that would represent if we went backwards in time 4.67 years?
Would it be 1979?
So it would be 1979. So think 1983 would represent -1. 1982 represents -2. 1981 would be -1. 1980, -3 would be -4. But I have to go an extra 0.67. So that means I have to go into 1979 to be beyond -4. So you can have a negative year. It just means you're moving backwards in time. So when we have this negative number, that actually means in 1979. So that's what -4.67 represents. And then she said 0% of households own a computer. So does that sound like that could be something that possibly could be a true statement? 1979, 0% of households own a computer? Anybody think? Your parents were probably born sometime in the 70s. Do you think they had a computer in their house? I bet you could ask. You might have some home right now. I definitely did not have a computer in my house until I was probably 13, maybe 14, which would have been the early 90s. And it was a big box computer and it had a green screen and it only typed in white. But corporations had computers. In the 60s, they had huge computers, took up pretty much like a school, the size of our schoolroom. But households didn't necessarily have computers unless you were one of those very high-end households. So this is true data, which is why sometimes we have old information to kind of get you to realize when things actually occurred, way before your time. But something to think about. You can't live without your device. People lived without computers on a daily basis in the 70s and the 80s. Questions? So we are going to look at another problem today, as I said. We're going to try and start to really think about those years and how the year would correlate with the information we're given. So try and think of a numerical value representing a year. This is what that -4.67, it represents the year 1979. But when we write our sentence, we want to make sure that we're using the year 1979 and not saying -0.467 years ago, this happened. So when it says in this situation, we try and relate it to the data we're given. Maddie, question?
Are we allowed to resubmit with any corrections that we make?
Always, yes. Yes, please. So anytime you make corrections on your assignments, yes, please always resubmit them. That's what I'm looking for, because that's the only way that right now I can tell if you're checking your answers and kind of going through that information. So please resubmit, yes. Other questions? So before we move on to the problem that we're going to do in the notes, Alyssa, question?
I had a question on, I understand what the x-intercept means now.
Yeah.
What about the y-intercept when x would equal 0? How is there year 0?
Yeah, that's a good question. Let's look at that right above. So the y-intercept is going to be 0 and 11.82. So just like we said, this is the year and this is the percent. So Alyssa, what year would represent the year 0?
Would it be 1984?
Yeah, And why is it 1984?
On the graph.
Yeah, on the
So
graph.
let 0.
Yep. So on the graph, 1984 is 0. In the directions, they tell us 1984 is 0. So for E, for the y-intercept, we would say in 1984, because that's the year 0. So you wouldn't say in the year 0. In the year 0 is 2020 years ago. 0 represents 1984 in this situation. So in 1984, 11.82% of houses owned a computer. Okay, so you might say, but that number that was in my chart is 13. 1984, 13% of households owned a computer. My number of 11.82 doesn't match up. And that's okay, because remember, this is our best fitting line. It's our average line. It's the line that fits to the data, trying to connect the data and make it a line, not make it a jagged line. So that y-intercept is not going to match with the data that's given, because our y-intercept is the best fitting line of the data. It's not connecting every single data point. Maddie, I saw your hand. You had a question?
I'm pretty sure, I don't know if this has to be done because I don't have it in my responses, but is it relevant? Like, do we have to have that it's U.S. households? Or
No,
does
that's
that,
okay. I mean, yes, it's relevant, but no, not necessary.
yeah, because
Good
I
question.
wasn't sure for if, like, later on in a test or something, if that
No.
would take off points.
No.
Okay.
No. Any other questions? Ava, did you have a question?
Me, Ava?
Ava R., I saw your hand.
No.
Okay.
Not the, might have been the one from before.
Okay. All right. Any other questions? That was a good question. The 1984, the y-intercept was a really good question to ask. So you can kind of see how like a y-intercept and an x-intercept would be phrased. So both of them start in a year and then a percentage of households owning a computer. So both of these questions here are going to be phrased very similarly when we're talking about years. All right, so we're going to go to the notes and we're going to see if we can do another problem like this. So if you want to turn, there's one more example in your packet. And it actually deals with the Olympics and the 100-meter dash in the Olympics. So the information we're given deals with the years from 1900s all the way up to 1972. So 28 would represent 1928, 32 represents 1932, and then so on. So does anybody know why the years jump by 4 years? Like instead of having every single year, we have 28 and then 32 and then 36. Jaden, why do the years jump like this?
Because the Olympics only happen every 4 years.
Yeah, the Olympics only happen every 4 years. Do you know why it starts in 1928?
Is it because the Olympics started in 1928? I'm not sure.
It's actually because women were allowed to compete in the Olympics in 1928. So
Okay.
the Olympics went before then, but women could compete starting in 1928. So again, it's real data that I'm pulling from different sources, and it's not just random information that I'm bringing about. So that's something to think about. This is real data. So when we want to put this in the calculator, this says that we're talking about the years in the 1900s. So you can use 28. You can use 32 because I could say that this represents year 0. So I could say the 1900s would represent year 0. 1900 is year 0. And then I could continue to place those numbers in the calculator. So why don't you take out your calculator, use the actual year 28. Don't put in 1928, just use the number 28. And then this goes up to 72. Yes, there are obviously more values that go beyond that. And notice that there's like make sure you're looking carefully. The years skip from 36 up to 48 because that was World War II and there weren't Olympics during World War II. So you can enter those values into your calculator. When somebody has an equation, if you mind sharing it with the class, I would appreciate it. And it says the least squares line, that's the same as the best fitting line, the linear regression equation. All those terms are interchangeable. Maddie, what do you have?
I just rounded to the second decimal place because that's what we've been doing.
That's
so
perfect. Yep.
I have y equals 0.02x plus 12.71. Oh, it would be negative 0.6.
Yeah, I got you there. And then you said plus 12.71, correct?
Yeah.
Perfect. Nice job. And then Maddie, what did you get for R?
I have negative 0.86.
Good. Yep. So the two problems, actually 3 problems, 2 from your homework and the one we did in class, plus then the age activity, they were all positive. It was increasing because the data was growing with time. In this case, the data is decreasing over time. And that's because this is a race. It's the 100-meter dash in the Olympics. And so as time goes on, runners get faster. They train harder. So that's why the data would be decreasing. Does this data form a perfect line? No, it doesn't form a perfect line. So I can't say it's linear unless the R value equals 1. Then it's linear. It might be close to forming a line, but it's not a perfect line. So I can't say that this is linear. We could also kind of note that it is decreasing. We could say it's a negative correlation. Those would be terms that you might see. So a positive correlation is going up, but negative correlation is going down. So if we kind of just work through the questions, making sure everybody feels a little more comfortable with the information. The slope of the line, Maddie gave us is negative 0.02. And then thinking about what that means. So remember, that really represents y over x. So thinking about what does the y represent and what does the x represent. Trying to write a sentence. And I think I missed the fact that this should be seconds here. I should have that labeled. So Valerio, can you write what the slope means in this situation? What does that negative 0.02 represent for slope?
The winning time is 0.02 seconds faster each year.
Yeah, I like that. Perfect. Very nice. So key things here, we have to have that it's each year, and the fact that it is faster. That's what the negative means. So you could also say that the winning time decreases by 0.2 or 0.02 seconds each year. You could have had every year the winning time is 0.202 seconds faster. Like you could have had the sentence flip-flopped as well. Does anybody have questions about the way you have your sentence worded? So make sure that you have each year, because this is happening every year, the fact that it's decreasing or the times are becoming faster. Those would be two things that I would be looking for. So question E asks us about the y-intercept, and we know that the y-intercept is that 12.71. Make it a point. All intercepts are points on the graph where the graph crosses the axis. And now I have to think about what the year 0 means in this problem. So what did we associate 0 with in this problem? And then what does 12.71 represent in our problem? Annabelle, are you able to describe what this y-intercept means?
In 1900, the winning time was 12.71 seconds.
Perfect. And if I look at my value, that number should be above the value for 1928. And again, women did not compete in 1900, but there could have been a male competing in the 1900 Olympics. All right, a few more questions. Letter F says, what is the x-intercept of this line? So see if you can get that x-intercept of the line. If you haven't done so already, set it equal to 0. And get the value for x. And then write it as an ordered pair. Faith, do you have the x-intercept?
Yeah, I got 635.5.
635.5?
Yeah.
Do you know what that means? So if we made year 0, 1900 was year 0, If we go in the future, 635.5 years, what year would that be?
$2,535.
So in the year 2535, the winning time is 0 seconds. What do you think? Could that make sense?
No.
I don't know. Maybe, maybe not. You never know what's going to happen in, I don't know, 500 years from now, right? Maybe. I mean, they could have some kind of invention that, but you'd still think it'd take like a split, like a partial second to get there. But yeah, probably doesn't make total sense, but who knows? We have no clue what could happen in 535 years or 515 years, really, from where we are right now. Questions? All right, so letter G says estimate the winning time in 1988 using your calculator. So again, we said 1900 was 0. So if we have 1988, we would plug in an 88. So we're going to take the equation and we're going to plug in 88. Gabby Snyder, can you take that equation, plug in 88, and get a winning time in 1988?
In 19. I'm sorry, I think I messed up my equation.
That's all right. See if you can plug this in. So negative 0.02 times 88 plus 12.71.
Uh, 10.95.
Great. And we're talking about seconds. Make sure we label that again. So in 1988, Florence Griffiths Joyner won the gold for the United States. She was the first female to win gold for the United States. That's why I have this number here. She won with a time of 10.54 seconds. It says make a conjecture about this piece of data based off of your estimation. So the number that we calculated is an estimation because our line is really an estimated line. It's the line that best fits the data. So you could say that she would be faster than the average line or the average speed, the average winning time that we have calculated for our data. Does anyone have questions about trying to write the sentences using the years? So the homework tonight is going to be, again, very similar to the information that you're given today, like with the years. And I'll just pull it up so that you can see what it looks like, especially, so the first one talks about broccoli and consumers, people eating broccoli, consuming broccoli. I don't like broccoli. It's one of my least favorite vegetables. Unless it's like just steamed a little bit with some butter and it's crisp, I don't really like broccoli. And then the second question talks about the life expectancy. Again, this one starts in 1920. And I know 1920 was 100 years ago, not 200 years ago, but 100 years ago. But that represents year 0. And then just be careful, it's counting by 10 years. So this would be 10 years later. This is 20 years later, and so on. So just be really careful that when you're labeling the years, you're recognizing what the information is counting by. So there is a reason why you're given older data, because it does have definitely correlations about life expectancy and how long a person was expected to live. That's what life expectancy is. So what is the average life expectancy for a person? We can definitely look up the average life expectancy for a person right now in 2020. It'll probably be higher than the data values that we calculate. Are there questions from the linear regression? So as I said, for tomorrow, please find a ruler. We're going to do one final activity dealing with the linear regression, trying to pair two sets of data together. You'll have a little review worksheet, and then on Thursday, we'll take a quiz on this linear regression. Any questions? If you did notice, you should have received an email saying that your score was released from Edulastic for your test that you took also last Thursday. So you can feel free to look at that. I type in comments for every question. If you have any questions on that first quiz, 2125, the quiz of this chapter, let me know. We'll be taking a chapter test probably when we're back in the hybrid model. So have a great day. If you don't have any other questions, we'll bring that ruler to class tomorrow. We'll wrap this up tomorrow.